Welcome class to this video on angles in polygons. To start us off, let's just go over briefly the definition of a polygon. A polygon is a many-sided figure. We should also note that it is always a flat two-dimensional shape, and it has the same number of angles as sides. I want you to recall, and you should remember from previous video, that the sum of the angles in a triangle is 180 degrees. And this is a very important fact for us that we will be using throughout this video to help us how to figure out the sum of the interior angles of any polygon. That's our goal, is to get to a formula and understand how that formula is derived. To do that, let's start by looking at a triangle. In a triangle, we have three sides, and when we have three sides, we have one triangle. And the sum of the interior angles of a triangle we just said is 180 degrees. What about with the quadrilateral? How many sides do I have for a quadrilateral? I have 4 sides for the quadrilateral. How many triangles do I have within the quadrilateral? You should see there that I have 2. And then what is the sum of the interior angles of a quadrilateral? We learned in section 8.2 that the sum of the interior angles is 360. And you should be able to see why that makes sense here, because one triangle is 180 degrees. So if we have 2 triangles, then we have 360, because 2 times 180, and that gives us the 360. All right. Hopefully you understood how we got 360. Let's try Pentagon. A pentagon has how many sides? It has 5 sides. What is the number of triangles? 1, 2, 3. So it has 3 triangles. Now how can we figure out the sum of the interior angles? Well, you notice how we did 2 times 180 here? We can do the same thing here with 3. 3 times 180, and we get 540 degrees. One triangle is 180 degrees. There are 3 triangles in the pentagon, therefore 540 degrees for the pentagon. Let's try a hexagon. The hexagon has 6 sides. And how many triangles is that one going to have? Let's draw it. So you would go from here to here, here to here, and here to here. You got to start from one vertex, and your triangles have to be non-overlapping to be able to see this point clearly. And let's count how many triangles that we then had. We had 4 triangles. So what do we do with that 4 triangles to find the sum of the interior angles that we're looking for over here? Just like the other examples, we're going to multiply it by 180. And if we multiply 4 by 180, we get 720 degrees. I wonder if you're starting to notice the pattern here in terms of the number of sides versus the number of triangles. So you can see we have 3 sides, 1 triangle, 4 sides, 2 triangles, 5 sides, 3 triangles, 6 sides, 4 triangles. So what was the difference between the number of sides and the number of triangles each time? Hopefully you recognized it. It's 2. So let's look at an octagon and see if that bears out as well. So we have here 8 sides for our octagon. Now let's go from one vertex and draw and connect all the other vertices so we can, or vertices, so we can determine how many non-overlapping triangles we're going to have. You should be able to predict the answer to this. There you go. And we have 1, 2, 3, 4, 5, and hopefully you were able to guess that we would have 6, right? And how would you have done that? 8 for the number of sides, subtract 2. The difference between the number of sides and the number of triangles is 2. So 8 subtract 2 and we get 6. Now how can we find the sum of the interior angles? We're going to multiply that by 180, and that is going to give us 1080 degrees. All right, so now we're almost there. We can now hopefully start to generalize how we would find the sum of the interior angles of any polygon. So I want you to imagine an n-gon. What is an n-gon? N just stands for number of sides. So n-gon means a polygon with any number of sides. And of course, those numbers have to be natural numbers like 1, 2, 3. We can never talk about having sides that are decimal. You have a 1.5 sides of something, for example. So we're going to label the number of sides for any polygon as n, right? Because n could be any natural number. And then now, how would we go about finding how many triangles are inside our n-gon, right? What did we do for all these other examples? 5 minus what gave us 3? 5 minus 2. 6 minus 2 gave us 4. 8 minus 2 gave us 6. And so we would take the number of sides from our polygon and we would subtract 2. That would tell us the number of triangles inside our polygon. Now, what did we do once we knew the number of triangles inside our polygon? We simply multiplied that by 180. And so here we have the formula that we are looking for. Using this formula here, I can find the sum of any of the interior angles of any polygon. All right, so let's do one example, and then hopefully you'll be good to complete the rest of the handouts by yourself, and it shouldn't be too difficult from there. So it says here, find the number of degrees in the sum of the interior angles of a decagon. And so a decagon, let's find decagon. A decagon has 10 sides. All right, so let's write our formula. What was our formula? 180 bracket n minus 2. Remember, n stands for the number of sides. So how many sides does the decagon have? It has 10. So we do 180 bracket 10 minus 2. What's 10 minus 2? 10 minus 2 is 8. And so we get 180 multiplied by 8. And our answer when we do that is 1,440 degrees. That's our answer. That is the sum of the interior angles of a decagon. Now I said I would only do one example, but I want us to do actually one more example, because how about if we had a question like this? At number 3, it says, how many sides does a polygon have if the sum of the interior angles is 720 degrees? So I want you to write the formula again. But this time I want you to think, what does this equal to? Well, it equals to the sum of the interior angles. You could basically use any letter here, but we'll use S to represent the sum of the interior angles. In this question, was I given the number of sides, or was I given the sum of the interior angles? I was given the sum of the interior angles. So I could replace S with 720 and then write my formula like this. And now there are a couple ways you could do this. You could apply, for example, the distributive property if you so chose. But easier than that is to divide both sides by 180. You see how we have multiply by 180 here? So we could divide both sides by 180. And when we do that, we're going to get, and I'm going to need to make some space for myself, so right over here, if I do 720 divided by 180, I get 4 equals to n minus 2, right? So 720 divided by 180 gave me 4 equals to n minus 2, and then what do I have to do? I have to add 2 to both sides, so I get 4 plus 2 equals to n. 6 equals n, or n equals 6, because a polygon that has the sum of the interior angles of 720 will be 6 sides.